Hey, how's it going everyone? In this video we're going to go over number of islands question. This is a popular question asked by major tech companies like Google, Facebook, LinkedIn, etc. This is a graph algorithm question. If you don't know much about breadth first search, depth first search algorithms, it would be a good idea to check them first and come back to the question after. So you can check breadth first search or depth first search on YouTube, Geeks for Geeks, or Wikipedia, etc., and come back to the question afterwards. So let's read the question and try to understand. Given a 2D grid map of ones, land, and zeros, water, count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So we have ones and zeros here that make up of a grid. Ones are lands, zeros are waters, and when we connect ones horizontally or vertically, they become a land. For example, in this one we have one land. All ones are either horizontally connected here or vertical connection here. Again, vertical connection here, vertical connection here, and this is one land here. So the output should be 1. In this one there's one land here. There's horizontal and vertical connections here. There's one land. There's another one here. And there's one land here. If you see a diagonal connection, you should just ignore, because we're only looking for horizontal or vertical connections. Only horizontal or vertical. So I have a few more examples here. So in this one we have one connection, one island here. All the lands are connected either horizontally or vertically. These two lands are connected horizontally. There's one land here, one land here, another island here, one island here. So we have 5 islands here. These diagonals, we should ignore the diagonals. Only either single one lands or adjacent connections. One island here, one island here, and one island here. So output it should be 3 in this one. So in this graph algorithms, we use depth first search or breadth first search algorithms to go through the adjacent cells and mark them. If you don't know much about these algorithms, it would be a good idea to go to learn first and come back to the question. So what we need to do is we need to go through with 2 for loops, nested for loops, and start from the top left and check if the item is a land or water. If it's a land, if it's 1, we simply mark it as 2. We simply mark this to increment our counter and say we found an island. Then send it to the DFS recursive function to check all the adjacent cells. The recursive function, what it does is, it checks this item. It checks all 4 directions: up, left, right, down. Checks all the adjacent cells and mark them as 2, like this. Again, this one comes, and this process is a recursive function, all done recursively. Top and left is done, so down, we don't need to worry about the down as well because there's water. In the right hand side we have another length, so we mark this as 2. The reason why we mark this is we go through using a for loop, and next time after this, when we come to this length, if we see length here, number 1, then we need to go through, we need to increment the number and do the same process again. So that would be wrong because all of them are connected and there's only one island here. We shouldn't increment the island counter when we see another 1 here. So that's why we increment this, and when the for loop goes through, it will not find another 1. And mark all of them using DFS algorithm. And same for this. The first one, we hit number 1. What we need to do is we mark this, increment the counter, and go to the adjacent cells, right, left, top, down. And there are only water here, so we're done here. This one again, we will mark this too, so next time when we iterate, we don't need to worry about it. So we check left and down for this, and there's nothing, so we continue. And same for this one, and same for this one. So I believe you understand the logic, so we can continue to the coding part. Okay, so num islands is our function, and we keep an island counter here. This is the counter, and initial value is 0. Then we have 2 nested loops, one for the rows and one for columns. When we hit 1, if grid is number 1, then we increment the counter. We found an island. We know that. But we need to check the adjacent cells. If they are also islands, if they're also 1, we have to turn them into 2s. So next time when we go through, we won't mark them as an island. So mark an island is the function. We are sending the grid and I and j indices, and finally return the island counter. Mark island function is a recursive DFS function. Gets grid I and j as parameters. There's one if statement that breaks the recursion. First we check if we are within the boundaries of the grid. If I is less than 0, I is grid length, j less than 0, j is grid of I that length. So we know we are in the boundaries. If we're outside of the boundaries, then we return. One final check is we're only interested in number 1s. We're only interested in lengths, because when we find the length, we check the adjacents and we mark it as 2. We're not interested in 0s or 2s. That's why we mark it as 2. We could also mark it as 0 as well, but marking as 2, so we can see the difference here. We see here it's not a length. We know that this is not the length, so then if this is not a length, we return. We are only interested in length. When we find the length, we mark it as 2. Then we call all the adjacent recursive functions as well. For example, for up, down, left and right recursive calls. Basically, we simply increment the index numbers or decrement to find up, down, left and right values. When this when this recursion is done, we mark all of them as 2s, so we don't increment the counter next time when we go through. So that's pretty much the idea. Let's run the code and see if it's going to work. Okay, it is accepted.